Hello and welcome to this lecture. We will go into using the select statement to query data from the database in DuckDB. Moving directly onto the slides we have here. So querying data in a relational database using DQL, data query language, and in more specifics we'll use the select statement, or using the select class to query columns. So here we have select star from data jobs. So data jobs is our data source. So it's a table or a view. And note that this works when the table is in the main schema. So you don't need to specify the schema name in beforehand. So otherwise you can also specify main.datajobs. But whenever it's in the main, you can directly query it like this. And this one, it is a wildcard, so it selects all the columns. So here we want to select specific columns. So choosing all rows of these columns. And now we use from main.datajobs, right? So here we use the schema name as well. So it's the namespace. And here we can also select, we can choose to exclude some of the columns. So we use select star and then we exclude different columns that we don't want. And this is a DuckDB feature, which doesn't exist in some other traditional database management systems. So choosing all columns except for those columns specified inside of the exclude. So here we have the database hierarchy to organize the database objects. So we have salaries, database, and we have the default schema, which is the main. And here we have custom schemas. For example, we have marts, we have refine layer, and we have staging. And you will go more into these later on when we come into the data warehouse course. So this is how we structure a data warehouse, basically. And we have tables inside of the marts, or we have tables inside of, it was inside the marts, correctly. And the hierarchy of database objects in DuckDB, it looks like this. We have database and we have several schemas, and in each schema we have database objects like tables, views, indexes, and functions. And in DuckDB, the database is in the file or in memory. And so it means that if you just run DuckDB in the CLI, you will get an in-memory database. So the database won't store somewhere. However, when you do DuckDB and the database name, then you will have a persistent storage. So it's in the file. And here the schemas are the logical grouping for database objects. And here we have all the database objects. So this is the hierarchy of the objects in DuckDB. And to sort the data, you use order by class to sort the data. So we have select star from main.datajobs. We have order by salary in US dollar. So here we sort by the US dollar. Sorts ascending by default. And here you can choose to sort descending if you want. And here you can also order by one column descending, and if it's a tie between two rows, between two records, and then you'll pick the second column and sort it. And here we have chosen ascending, so basically alphabetically. And I don't show the data here because this is just the theory part, and then we will show the data when we do the practice, the code along. So here we sort by the first column descending. If tie, it sorts by second column ascending. And we have already touched on it, but we create namespaces to organize the data, right? Or the databases, organize the tables. So we have select star from main.datajobs. Here we have a schema namespace. It looks into the main schema and check for a table called datajobs. Here we do select star from salaries.main.datajobs. So this is the fully qualified name, using fully qualified name. And this is good for avoiding name collisions and better organizations with namespaces. So if you have several schemas and you can have the same table name basically, but in order to go into each, in order to select from each table, you need to use the namespace, and the namespace is basically the schema name. And here we'll go into the alias. So use alias with the as keyword to name columns. So you have here select count distinct salary currency as number currency. So it becomes, this is your column name now. Otherwise it will say count distinct salary currency, which is not that, it's not, the name is not so descriptive. So select the unique values in this column. This is how this distinct works. And the count, it's an aggregate function that counts the number of occurrences in the column and returns a value. And here we use the as to rename the columns. And you can also do it like this. So as keyword is optional, so space works as well. However, you need to pick the option that gives best readability and be consistent. So if you think that the as is better for readability, then use this one. I tend to use the as keyword. I want to be more descriptive and more towards readability. So we can use the alias without the as keyword to name columns. So we do like this. This optional space works as well. Choose the option that gives the best readability and be consistent. We have aggregate functions to combine multiple rows into one value. So here you have a lot of rows, means that is salary in US dollar. We choose the min of it. So basically we have a lot of rows. We squash them, choose one, that is the minimum. Here we have average. So we take everything in the row and we calculate the mean value. And so it returns one value. Similar here, median returns one value, max returns one value. So this gives us descriptive statistics. And with this, I would like to thank you for watching this video and see you in the next video where we'll go into the actual coding part, where you'll see the results of many of these queries that we've shown here. So thank you. See you in the next video. Bye.